Okay, class, today we're going to look at lesson 6.7, multiply and divide inequalities, multiplication and division inequalities, one-steppers. So this is very similar to what we did with equations. There's just one major difference. When we're solving inequalities, we solve them basically the exact same that we solve equations. Today we're going to learn about one very, very crucial difference, which is the only real thing. If you can remember this one difference, then you can remember basically how to do them, because they're just like the ones we did for equations. So we're going to do one-steppers, and then 6.8 is the last lesson where it's two-step inequalities. Okay, so let's just go ahead and dive right on in. First problem is like this. 8x is less than or equal to 40. Okay, 8x is less than or equal to 40. So we do go through our normal steps, exact normal steps, right? Let's go ahead and draw our wall. We identify the variable over here on the left side, which is x. We have that 8 multiplying. So how do I get rid of multiplication, right? We're going to say, okay, well, I need to divide by 8 on both sides, right? Divide by 8 on both sides. Let's go ahead and do our division here. So that cancels out. We're left with x, and this is 840 divided by 8, which is 5. And then sometimes people just kind of instinctively, they just put the equal sign there. So make sure you put the less than or equal to, the sign that was just right above. And there you go. So x is less than or equal to 5. Let's go ahead and graph it, and then we'll check it, okay? So again, when we're graphing, all you need is that center number, which is 5. Okay, so now remember from our last lesson, we have to think about open or closed. So we have this equal to sign right here. So it's going to be a closed dot. And it is less than. Less than is going to be the left than. That's the way I like to remember it. Less than, left than. Okay, so we're going to go this way. Now, when you check these problems, what I like to do is actually, I like to try just any number that should be on this line right here. So for example, if we tried -7, if we did this right, -7 should be a possible answer. So let's check it. Here we go. 8 times -7 should be less than or equal to 40. Is that correct? Well, yeah, this is -56. That is definitely less than or equal to 40. So that checks out. Another way you could do it is you could look on the other side and say, well, a number like, what's bigger than 5? Let's see. 8. 8 is bigger than 5. All right, so 8 is bigger than 5, so 8 should not work. Let's try it. 8 times 8 is less than or equal to 40. Well, we know this is not true. 64 rather. Oops, my mistake there. 64 is not less than or equal to 40. So this one does not work. And that makes sense. So that's how you can try and check these answers, and then I like to put a little box around it. So you need to be able to do both things. You need to be able to both put the answer and graph it. And that's it. That's just one step. Real easy, one step inequalities. Let's go ahead and do another one here. Okay, how about this? D over 2 is greater than -7. D divided by 2 is greater than -7. All right, so let's go ahead and solve it. I see that there is a divided by 2, so I'm going to multiply by 2, or 2 over 1 on both sides. Cancels. What am I left with? I've got D, and I've got -14, greater than. All right, let's go ahead and graph it. Here's -14. This one is going to be an open dot, right? Because there's no equal to, so it's going to be open. -14, remember, that means that -14 is not a possible answer. But that's our starting point. And it's greater than, so it's going to go this way. Let's check. Let's just check a number that's greater than -14. We can make things really easy. Like, for example, a positive number, like 1/2 or something like that. Like all the way over here is the number 1. Is 1 greater than -7? Of course it is. That would check out. So really simple. Again, all you're doing is you are going to multiply or divide to solve these problems, and then make sure that you graph. Okay? All you have to do, multiply, divide, and then go ahead and graph. Okay. So now, so this is the most basic. This is just like what we did with adding, subtracting. This is in our last lesson, right? Just one step and you're done, and then the graphing part. And then it's also just like solving regular equations with multiplication and division. Okay, so now what about the one thing that makes things different is this, okay? When you multiply or divide by a negative number, something happens. You need to flip the inequality. What do I mean by flip the inequality? That means that greater than or greater than or equal to becomes less than. And less than becomes greater than or equal to, okay? So greater switches to less. You literally flip over the inequality. So we're gonna do some examples with that real quick here, okay? All right, so let's go ahead and do an example. Negative 2g is less than 10. Negative 2g is less than 10, okay. So again, we're gonna solve this the exact same way that we did a and b up here, okay? I see multiplication, so I'm gonna divide, right? I'm gonna do the exact same way, okay? But here's the difference. Remember, this is not, you don't plus 2, this is negative 2 times g. If you need help there, the parentheses might help there. Okay, so I need to divide by 2, both sides, or divide by negative 2, rather. And I'm left with, that cancels out, g, and this is going to be negative 5. And then again, this is the part that's key, right here. This is the one rule. This is the one rule. This is the only thing that makes inequalities, solving inequalities, different from solving equations. The less than becomes greater than. The less than becomes greater than. Okay, so I want you to look very closely right here. The less than becomes greater than. Let's go ahead and graph it. Here we go, negative 5 right there in the middle. There's no equal to sign, so it's going to be an open dot. We see that it's greater than, so it's going to go this way. Let's check it. Let's just try a number here. How about negative 3? Okay. Negative 2, so there's our check work here. Negative 2 times negative 3 should be, okay, less than positive 10. Let's see. Negative 2 times negative 3 is positive 6. That is less than 10, so we did it correctly. This is our answer. Notice, if we would have tried a number that is less than negative 5, like if we did not flip the inequality, so let me just give you a real quick example here. So let's just say we tried a number over here, like, I don't know, this is like negative 8, okay? This should not be a point. Negative 8 should not work, so let's check it, okay? Negative 2 times negative 8, okay, should be greater than 16, than 10. Oh, sorry, it should be less than. I got to go back to the original problem. This is 16. Is that less than 10? It is not. So this one should not work, and it doesn't. It's not part of our line. Okay. So again, the most important thing is that you flip the inequality. Okay. This part that's highlighted in green, right? Less than became greater than. When you divide by a negative. not when you add or subtract. Never, it had nothing to do with add and subtraction, only when you divide or multiply by a negative. Okay, let's try another one here. Negative 4y is greater than negative 16. All right, let's go and solve. I see that's negative 4 times y, so I'm going to divide by negative 4 on both sides. That cancels out. All I'm left with is y. This negative 16 divided by negative 4 is positive 4. And then again, I have a greater than, which is going to flip over to a less than because I divided by a negative. Okay, divided by a negative. So again, what happened here? I divided by 4 by a negative 4, so I flipped inequality. Okay, let's graph it. Let's just make sure. Let's graph it. So here's our graph. Here is positive 4. We've got an open circle, and it's less than, so it's going to go this way. Let's keep going. Okay. X over negative 3 is less than or equal to 4. And when you look at these, you should be able to tell if you're going to have to flip or not, even before you do it. You should be able to see, okay, what step am I going to do? And will that be a step where I need to flip? Okay, so I see that negative 3 over on the left side with the X. So I'm thinking, you know what? I know I'm going to have to do something with that negative 3. That means I'm probably going to have to flip it. Let's multiply by negative 3, right? So times negative 3 over 1. Canceled out here. X, this is going to be a negative 12. And then again, I multiplied by negative 3. So that means, do I need to flip? The answer is yes. I do need to flip. Flip my inequality. Less than or equal to becomes greater than or equal to. Let's go ahead and graph. Here's negative 12. There is an equal to sign, so that's going to be a closed dot. It's greater than, so it's going to go this way. All right, here we go. Let's try one more. 5x is less than negative 15. All right, so here we go. We see that. We say, okay, here's 5 times x. So I'm going to divide by 5. X, and that's going to be negative 3. Now here's a question. Do I flip or do I not flip? Well, let's think about it. Again, did I multiply or divide by a negative? Again, not the number that started, not the number on the right side. The number next to the variable, was that negative? Did I divide by 5? Divide by negative 5, right? It doesn't matter if the answer is positive or negative. That's what some people get confused. They say, well, if the answer is negative, then I got to flip. No, it only matters if you divided by what number you divided by. And if that's negative, then you flip it. If it's not, you do not. So did we divide by a positive 5 or a negative 5? We divided by a positive 5. So that means we do not flip. Okay. So again, it doesn't matter if the answer is negative. It doesn't matter if you add or subtract. It doesn't even matter. Those things don't matter. All that matters is, did you, the number that you decided to divide with, or the number that you decided to multiply with, is that negative? Okay. So this one actually is going to stay the exact same. Notice again, okay, if you look at, I divided by a positive 5, I did not flip. This one, I multiplied by a negative 3, so I did flip. Going back here, I divided by a negative 4. This is that number, okay? So I did flip, okay? On this one, I divided by a -2, so I did flip, right? So that's the difference. You have to understand what you are dividing by. Again, the outcome could be this negative, it could be negative, it could be positive. It doesn't matter. What matters is what you did. Okay. So this one stays the same. If we graph it, real simple, no equal to. So it's going to be an open dot, less than, going to the left. So this is the big thing on today's lesson. If you understand that part, should I flip the inequality? Did I divide or multiply by a negative? That's the whole thing. If I divide or multiply by a negative, then you flip the inequality. You change your greater to your less than, and your less than to your greater than. That's the only rule. That's the only thing that makes any of these different. Okay, so hopefully remember that rule. We'll look at it again in the next lesson as well. But other than that, everything else is exact same in terms of solving inequalities and equations.